we've looked at the basic idea of probability. Now let's take a look at an important aspect that is particularly relevant to naive Bayes, and this is called conditional probability. Okay, so let's take this example. Again, you've got a set of people, some of whom are buyers, the ones with filled circles, and some of whom are non-buyers, the ones with unfilled circles. Okay, now what we've done is, apart from breaking people into buyers and non-buyers, we also have another category, which is the country to which a person belongs. Okay, so we've got two intersecting categories, buyer, non-buyer, and Canada, US, or Mexico, the country to which somebody belongs. Now, given this scenario, of course, what we have is the possible values of country or Canada, US, Mexico, and the possible statuses for a person or buyer or non-buyer. So if you use the expression P, Canada, and that stands for probability that a randomly chosen person has the country Canada, right? Because now we have two dimensions, the country and the status. So here, when we say P Canada, we're really saying that it's P country equals Canada. Of course, in this example, we don't really have to prefix the name of the attribute like country or status, because it's pretty obvious from from the value itself. Okay, and P buyer stands for P status equals buyer. So with that, we can say P buyer is 12 by 36 because there are 12 buyers here. If you count these filled circles, you will find that there are 12 of them, and there's a total of 36 circles overall. So the probability that a randomly selected person is a buyer is 1/3, or 12 by 36. And of course, probability that a randomly selected person is a non-buyer is 24 by 36, or 2/3. Okay, and that is because in this particular example, a person can only be either a buyer or a non-buyer, and those are mutually exclusive. They add up to 1 in this particular case. Okay, so once again, we can also calculate probabilities for the country dimension. So probability that a person is from Canada is 0.28, which happens to be 10. There are 10 people in this region marked Canada in this rectangle, and there's a total of 36, so it's 10 by 36 or 5 by 18, which is 0.28. Similarly, we can calculate the probabilities for a randomly chosen person from being from the US or being from Mexico. So these are all simple probabilities that we can calculate based on what we had learned in the previous lesson. Okay, so these formulas help us to calculate various probabilities for a randomly chosen person, these expressions really. Now we want to talk about this concept of conditional probability, right? So when we say conditional probability, we are saying, look, some aspect of the probability is already laid down. So for example, let's say we pick a random person, not from the entire population, but a random person from Canada, right? Which means that we are only interested in all the people belonging to Canada. Okay, so obviously, if you consider that scenario, if you consider only Canada, there is a total of 10 people in Canada, out of which 3 are buyers. And therefore, the probability of a person being a buyer, given that the person is from Canada, happens to be 3 out of 10. Remember, without that, the probability in general of a person being a buyer was 1/3, 12 by 36. But once you fix the country, then the probability can change, right? So that's what we are talking about here. And that is conditional probability. Given that the country is Canada, the probability of a person being a buyer is 0.3, 3 out of 10. Okay, whereas independently, it was 1/3. The way in which we state this probability, just in terms of notation, is probability of status equals buyer, vertical bar, given that country equals Canada is 0.3. Okay, so this vertical bar in the parlance of probability means given that something is true, right? So probability, of course, we could write this by leaving out status and country as simply probability buyer given Canada equals 0.3. That's what we have done here. Okay, and the general notation is probability A given B. That's how you read it. Probability of A given B. So you read the vertical bar as given. Okay, that means some condition is known or assumed. So given that that is what has happened, then what is a probability is different from the independent probability of A, right, which changes when you have the condition B, which is already given to you. Okay, so here again we say probability. Now we are considering the reverse, which is given that status is buyer, right, which means that we are only interested in people in the points that belong inside this large oval, because that consists of all the buyers, right? So given that status equals buyer, what is the probability that the country is Canada? Okay, so in this case, what happens is, given that the status is buyer, we restrict our attention to these 12 points. And out of those 12 points, 3 are in Canada, and therefore the probability is 3 divided by 12, or 1 by 4. So what we did here was we picked a person at random, right? And we see that the person is a buyer, right? Which means we are given that this person is a buyer. Now we ask the question, what is the probability of this person being a Canadian, right? So given that the person is a buyer, this person is obviously one of these 12. Now we want to find out what is the probability that the person is one of these 3. So it's going to be 3 divided by the overall 12. Okay, so it's 1 by 4. Okay, so given randomly pick a person, what is the probability of being a Canadian buyer, right? So this time we're not saying that the person is, given as a buyer or given as Canadian. We are just saying if you randomly pick a person, what is the probability of a person being a Canadian buyer, which is we are talking about the probability of P Canada and buyer, or P Canada comma buyer. Okay, so obviously there are 3 Canadian buyers out of a total of 36. So the probability turns out to be 1 by 12, okay, which is different from the probability of Canada multiplied by the probability of buyer, right? Probability of Canada, we already saw, was 0.28, 10 divided by 36. And the probability of buyer is 1/3, right? So if you multiply those two, you don't get 1/12, right? So 10 divided by 36 multiplied by 1 by 3, right, is 10 divided by 108, which is not 1/12. Okay, the reason being that the two are not independent. If they were independent, you could have independently multiplied the probabilities of each of those and got the joint probability, but they're not independent, so that's why it doesn't work here.